Good morning. Today, let us go to the next topic, random process. Already, we have discussed random variable. So, assigning a real number to an experiment is said to be a random variable. So, random process is a collection of random variable x of s comma t that are function of real variable t, where s belongs to x is a sample space and t belongs to t. So let us now compare the random variable and random process. Random variable, a function of a possible outcome of an experiment. Outcome is mapped into a real number. A function of random process, a function of the possible outcome of an experiment, and time, also time x of s comma t. In random process, the outcomes are mapped into waveform, which is the function of time. So we have the classification of random process, that is, when the state is continuous and time is continuous, we say it is continuous random process. When the state is continuous and time is discrete, we say it is continuous random sequence. When the state is discrete and time is continuous, it is discrete random process. When the state is discrete and time is discrete, it is discrete random variable sequence. So we have another classification, stationary process. A random process is said to be stationary if its mean and variance does not depend on the time. That is, mean is denoted as E of x of t is a constant and variance is also a constant. It should be independent of time. Evolutionary process. A random process that is not stationary, that is, either mean or variance is not constant, it is said to be evolutionary process. So, which is not constant, stationary is said to be evolutionary. First order stationary process. A random process is called first order stationary if it is first order density function does not depend on time t. E of x of t is equal to constant. So the first order is the mean. If mean is constant, we say it is first order stationary process. White-sense stationary process. A random process is said to be White-sense if it satisfies E of x of t, mean is constant, and autocorrelation is a function of tau. So tau is the time difference. R or x comma x of tau equal to E of x of t and E of x t plus tau. The next is joint while sense stationary process. Two processes x of t and y of t are said to be joint White-sense stationary process if r of xy tau equal to e of x of t, y of t plus tau. Strict sense stationary process. A random process is said to be strict sense stationary process if all its statistic property do not change with time. So what are the statistic property we see? Mean, variance, moment, all those are independent of time. It is said to be strict sense stationary process. So, from the definition of the strict-sense stationary process and White-sense stationary process, we got the result that every SSS, strict-sense stationary process of order 2 is White-sense stationary process and vice versa is not conversely. Let us go to the problem. The process x of t whose probability under certain condition is given by p of x of t equal to n, that is at power n minus 1 by 1 plus at n plus 1, n equal to 1, 2, etc. When n equal to 0, it takes the value at by 1 plus at, 1 plus at. Show that it is not stationary. So we have to prove that it is not stationary. Either one, that is mean or variance, is not constant. So the probability distribution is given as x of t takes the value 0, 1, 2, 3. So the corresponding p of x is at by 1 plus at, 1 by 1 plus at square, 80 by 1 plus 80 cube, 80 square by 1 plus 80 power 4. So in order to prove this stationary, we will prove that the mean and variance are not constant. So let us continue the proof in the next class. Thank you.